So this is the function I was talking about, the identity function. So the identity function is a line. This is not the only equation of a line. You may recognize lines as being y equals mx plus b. So that is another format for a line. Now that would be a linear function, not the identity function, because in this case, your input doesn't necessarily match your output. For the second function that we'll be looking at in this class, that is the squaring function. And the squaring function should look familiar. It is a parabola, x squared. So when we're looking at this function, you should be able to call it by its name, a parabola. And then again, similar to the identity function, this is what we will call the parent function, the most basic form of a quadratic function. So this is a parabola. You should also know that it's called quadratic. Quadratic, let's put that. Okay, the way that we can identify when a function is a squaring function compared to a linear function is we look at the exponent. The exponent here of our variable, and we're looking for the highest degree. So in this case, our exponent has a degree 2. So that's another way of identifying when a function is the squaring function. It has a degree 2. So our next function is the cubing function. There we go. So the cubing function is with x cubed, or x to the third power. And when we're looking at a cubing function, we'll notice now our degree is 3. So those are our polynomial functions. And then we go into our non-polynomial functions. For example, the reciprocal function. This is what's called a hyperbola. And we're going to talk about hyperbolas toward the end of second semester in more detail. But the important thing to know about this 1 over x function is that if we look at the graph, as it gets closer and closer to an x value of negative infinity, as it goes off to the left, it's always going to go along the x-axis, and it will never cross the x-axis. So my x values, as they get smaller, my y value gets closer and closer to 0. We call this behavior where it approaches a line asymptotic. So when we look at end behavior of a graph, when we're looking at a graph, and the graph goes close to a line, but it never touches it. So they'll get closer and closer and closer and closer together, but they'll never quite touch. We call that behavior asymptotic. And that red line that I drew is called an asymptote. Notice the same type of behavior happens as x is getting bigger. On the right-hand side, the graph also gets closer and closer and closer to 0, but it will never cross that x-axis. And then we have a very similar behavior as the x values get closer and closer to 0, where our graph is going to approach the y-axis and never cross. And so we actually have 2 asymptotes in this graph. And it is those 2 asymptotes that make this a hyperbolic shape, or a hyperbola. The next function we'll be looking at is the square root function, right? So if we look at a parabola, the x squared, or the squaring function, has kind of this U shape. If I were to have that parabola fall over on its side, it would have kind of a C shape, but that's not a function. And so what we do is we only look at one arm of the graph. We say, okay, I'm only going to choose to look at the positive roots. And so we end up with the square root function. The word that we use to describe this, that we're only selecting half of our solutions, is we call them principal roots. Just the positive ones. And that's the reason when we calculate a square root, we can just say that the square root of 4 is 2, even though negative 2 squared is also 4. So this is the reason we say that the square root of 4 is 2, so that we can always have a function. And that way, when I calculate the square root and you calculate the square root, we will always end up with the same answer. The reason the parabola falls over on its side is that these 2 functions are inverses. And when we're looking at inverses, the way we can tell that they're inverses is they have this line of symmetry, and that line of symmetry is the identity function. We can also take a cube root or any odd root as well. And if we're taking an even root, they will all look like this. the square root, the fourth root, the sixth root will all have this shape. If I take a cube root, the difference is that now I can have negative answers. So when I have the cube root of x, the graph goes off in both directions. So it makes kind of that square root shape, but it also has negative solutions. So when we're talking about an exponential function, I can say a population is doubling every week. That would be exponential because I have a certain population, it doubles, and then that new population doubles again, and the new population doubles again, and it grows very, very fast. And the way we can identify an exponential function is that our exponent is a variable. So the key for an exponential function is that the variable is in the exponent. This base e is a number. E is a number. E is about 2.7. And the reason we have E is because it comes up a lot when we're calculating about natural phenomena. And here again, we see this asymptotic behavior, where we can see that the tail end of this graph goes out along the x-axis, but will never cross it. So here's another example of an asymptote on the x-axis. Our next function is very closely related to the exponential function. It is the logarithm function. And here we see the natural logarithm function. And what that means is that, let's see here. Okay, what that means is the base of a natural log is e. Remember, e is a number. So when I read this equation, I would say the function of x log base e of x. Let me put it here. Log base e of x, or because this is a natural log, let's see if I can put this on the white so you can see it a little bit better. We can say natural log of x. Those two things mean the same thing. On the last slide, we had our exponential function looks like this. And I had mentioned we'll be seeing another pair of inverses. Well, this is also two inverse functions. So if I draw that identity function, notice how there's this reflexive property. And then just like we had an asymptote for our exponential function, for our logarithmic function, our asymptote is now on the y-axis. So the role of the axes switches for our inverse functions. The next two functions we're going to talk about together are sine and cosine. So let's look at the sine function first. Now, if you have not taken geometry honors and you have not seen trigonometry, I posted a resource on Blackboard so that you can kind of watch through those trigonometry intro videos. And the unit circle is a circle with a unit radius, meaning the radius is 1. So it's a very special circle. And because the radius is 1, the way that sine works is it plots all of the y values of the unit circle. So my highest y value is 1, my lowest y value is -1, and that's why we could sandwich sine between 1 and -1. In tonight's videos, you'll learn that that's called being bounded. Okay, our next function that we're going to look at is the cosine function. And the cosine function also comes from the unit circle, and it is also bounded. And the reason that it's bounded this time is because cosine comes from the x values. But my biggest x value is still 1, and my smallest x value is still -1, okay? Our next function that we'll look at is the absolute value function. So again, this is one that you should hopefully be familiar with. The absolute value function comes from taking our identity function, in this case, and taking all of those negative values and making them positive. So absolute value represents a distance. And since it's a distance, it can never be negative. The greatest integer function is essentially the round down function. So if I have 1.2 If I put it into the integer function, it will just round down to 1. 7.3 down to 7. 9.8 down to 9. So it's cutting off that decimal. And the reason I want to show you this is because I do mention it in the video that you're going to watch tonight, but we'll talk about it in more detail next class because I don't want to keep you over. So I'm just going to show you, this is the 12th function, but we're not going to talk about this one until we get to the unit where we can dive in, because I assume none of you have ever seen this before. So your homework for tonight is an Edpuzzle video, and also to prepare for the MDTP, because next class, no lesson, you're just taking the MDTP.